Today is the day that we get to the beloved formula, guys. So I'm sure you're all super excited on this one. Today we are going to be talking about slope intercept form. Okay, so when we are talking about slope intercept form, remember we are graphing linear functions, and we're graphing linear functions in specific forms. So we've already talked about standard form. Now we're going to be talking about slope intercept form. So if we are talking about slope intercept form, okay, we're now looking at something that's in the form y equals mx plus b, right? There it is, the beloved formula, where there are two things that we can find in slope intercept form. The first thing that we can find is the slope. And we should know at this point that slope is represented with the letter m. So our m right here, whatever number's sitting in front of the x is our slope. And we can find our y-intercept, which is going to be represented with the letter b. Now, mathematicians aren't always the most creative people, right? So this is called slope intercept form, and there are two things that we can find, a slope and a y-intercept. Okay, it's pretty straightforward. It is in the name. So we're going to talk about how we can identify the important information and how we can then transfer this onto a graph. Remember, without having to go through all of those other crazy steps that we did when we were just graphing all functions. So let's say we want to graph y equals 3/4 x plus 1. Okay, just like standard form, we want to find the two important things. Okay, and the two important things we said are the slope and the y-intercept. Good news, we don't have to do any work. We literally just have to pull them out of the equation. So as long as we're in y equals mx plus b form, we're just going to identify where m, the slope, is the number sitting in front of x, and b, the y-intercept, is the number that's not with x. It's our constant. So our m is 3/4, our b is 1. Okay, now when we go to graph this, our first step is going to be to plot the y-intercept. Okay, so I'm going to get a coordinate plane out. And we want to plot our y-intercept, or our b. So if our b is 1, it's our y-intercept, which means we need it to be on the y-axis. Okay, so we're going to go on our y-axis to 1. Okay, that part is very similar to what we did in standard form. Okay, but now instead of counting or going to our x-axis, our x-intercept, man, I can't talk today, our second step, okay, is going to be to count from that point. Not from the origin, not from another place on the coordinate plane. From that point we made, our rise over our run. So it's going to be really important here that our slope is in fraction form. Okay, so our rise over run, 3/4. We want to rise 3 and we want to run 4. So from this point, I am going to need to rise 3 and run 4. So I'm going to rise 1, 2, 3. And I'm going to run 1, 2, 3, 4. I'm really sorry, my marker touched the paper there. You don't actually want to make a dot there. You're just counting and pausing. Now, my suggestion is, just like we've talked about before, while 2 points make a line, 2 points always make a line, even if we counted our slope wrong. So my suggestion is going to still be to make 3 points. If you make 3 points, you'll know if you miscounted somewhere. So we're going to count again. 1, 2, 3, 1, 2, 3, 4, right? We want to make sure it looks like a line, and just like before, nice long line, because we know that this continues on, right? It's every x and y value that makes that function rule true. And there is our graph. Okay, so let's look at a second one. Let's say we want to graph y equals negative 3x plus 7. Okay, so we're in y equals mx plus b form. So our m is negative 3. Our b is 7. Okay, so we're going to plot our b first. So I'm going to go on my y-axis to 7. Now, for my slope, I want rise over run, which means I want it in a fraction, and negative 3 is currently not a fraction. So to make it a fraction, I'm just going to put it over 1, right? Any number over 1, I can turn that into a fraction. Okay, now negative 3 means a negative rise, remember? So that's down. So this is a down 3, but it's still over a positive 1. So while I'm going down 3, I still need to go right 1. And I'm going to count that again. Okay, and a good thing you can always do to check, remember we said negative slope should be going downhill from left to right, so make sure you have a downhill line. How about y equals 7x? Okay, so if we look at this one, our m is pretty straightforward, right? The number in front of the x is the 7, but we don't see a b, right? So what's really being added here that we don't see, that's 0. I know you'll have to think in your brain, but that's our additive identity, right? What can we add that doesn't change the value? That's a 0. Okay, so we're going to start at 0. We want our slope to be a fraction. So from 0, I'm going up 7 and over 1. Now I run into a problem because when I go to count up 7 and over 1 again, it doesn't fit on my graph. And I really said I would strongly recommend 3 points. So we need to think about how we're going to get a third point on here without going off of our coordinate plane. Okay, and the way we're going to do that is by making an equivalent fraction that includes negatives. And that I'm going to do by changing the sign of both of the numbers. So a positive 7 becomes negative, a positive 1 becomes negative, right? And 2 negatives make a positive, which means it's equivalent, maybe not reduced, but equivalent. So I can go down 7 and left 1. Now, you wouldn't have to write that slope down with the negative signs. You can just know that that's what you need to do. Okay, how about y equals 4? Okay, so m on this one. M is always the number in front of x, and 4 is not in front of the x. So since 4 is not in front of the x, it's by itself, that's our b. Okay, we see 0 x's in this problem, so our m is 0. Right, it's the same thing as saying y equals 0x plus 4. Okay, so we're going to start at 4. If our slope is a fraction, 0 over 1 is still a fraction, so we can do that. We're going to go up 0 over 1, up 0 over 1, and we get a horizontal line, which makes sense because that is what something with 0 slope looks like. What if we want to graph 4x equals y plus 2? Okay, so if we look at this one, it's not quite in y equals mx plus b form, which is a bummer. So we can't just find m and b. So instead, we need to do some rearranging to be able to figure out what m and b are. And I can do that by getting y by itself, right? Slope-intercept form says y equals. So I want to use those rules of a literal equation. If I want to get y by itself, I want to move this 2 away from it. I'm going to undo adding 2 by subtracting 2. Now, I kind of have those flip-flopped, right? But this is the same thing as saying y equals 4x minus 2. Okay, so my m is going to be 4. My b is negative 2. So I'm going to start at negative 2. Up 4. Up 4. And there is my line. One more with graphing. Let's say we have 3x plus 2y equals 8. Okay, this is also definitely not in slope-intercept form. And my students will often look at that and go, perfect. It's not in slope-intercept form, but it's in standard form. So let's just find the x and y intercept. And that sounds fine, because if we cover up and we divide by 2, we get y equals 4. Our y-intercept would be 4. But now if I cover up here and I divide by 3, I get x equals 8 over 3. And plotting an x-intercept of 8 over 3 means I'm going to have to round, and that is not the direction we want to go, right? Mrs. McKinney does not like to round or approximate. However, we do know how to solve this for y. And so if standard form doesn't work, slope-intercept form is another option we can then consider. So now we can solve this for y with the rules we've been talking about for forever, right? I told you solving for y was not going away. And I can divide by 2. And so while I would have had to approximate in standard form, I don't have to approximate in slope-intercept form, right? This says that my b is 4, and my slope is down 3, right 2. Down 3, right 2. Then one last quick addition we are going to add here is that this works in both directions. Okay, so just like I can take that information and create the graph, I can be given the information and create the equation. So if I'm told that m equals 3 and b equals -5, I can just as easily plug that into point slope form and say, okay, y equals 3x minus 5, right? I can go in between all those forms, just like we said we could do with functions, right? A graph, a table, a mapping, an equation. They all are interchangeable and different ways of representing the same information. Okay, so if I was just given this graph, I could say, okay, this has a b at 1, right? My y-intercept equals 1. And we already know how to calculate slope. My slope goes up 3 and over 4. So that is therefore the equation y equals 3/4 x plus 1.